Okay, so now let's go ahead and reverse all this. What I've been doing is giving you information, and then we find a function that fits the info. Here I've actually given you the polynomial, and I'm asking you to give me a sketch of the graph. Again, there's going to be some important points that you should be able to find. Intercepts should be important. End behavior should be important, right? And the multiplicity, how we're crossing the x-axis at these intercepts, should be also in detail. If you can get those things, you'll be fine. So let's take a look at this. First, what I would do is just take a look at the degree. There's one linear factor, another linear factor, and another one. And notice that all their multiplicities are 1. So our behavior crossing the x-axis is going to be like a line. So we'll be crossing the x-axis at all these locations. Where? Well, one of them is at -2, 0. This would give us 1, 0. And this would give us 3, 0. So I already have 3 points to plot. -2, 0, 1, 0, and 3, 0. Alright, we could also find the y-intercept, right, by just plugging a 0 in there. So when I do that, that'll give us another data point to plot. So again, intercepts are always good. So this is -1/3. We got a 2 times -1 times -3. A negative times a negative times a negative is a negative. 3's will divide out, and it looks like we end up at -2. So 0, -2 is another data point on this graph, right? So we got 4 data points. We know we're behaving like a line. What other information can we gather? Well, what about the end behavior? This ultimately, if we were to multiply all this together, x times x times x, we're going to have an x cubed plus a bunch of other stuff that comes up. And the lead coefficient is right there. So we're a cubic graph, and our lead coefficient is negative. So that means our function, right, is basically on its way down. So it's going to be going to positive infinity this way and negative infinity this way. So I think this gives us enough information to sketch the graph. I would have to come down to the x-axis and then go through the y-axis and then come back up to the x-axis and then come back down and then continue to go in that direction. So there's a really quick sketch of that graph based off of the zeros that I have, which means the x-intercepts that I have, the y-intercept that I have, and then using our end behavior. Of course, if I wanted more detail in this graph, I would do some more point plotting. So, maybe I figure out what's happening at 2, right? What's happening at -3, what's happening at 5. But I'm just asking for a sketch, all right? And so that's all we're really after there. So how about, why don't we check how accurate I was, right? We'll go ahead and go to our technology here. First of all, let me go to my standard viewing rectangle. I think I changed it earlier, and that's some other graphs. Let's go to, to y equals. I'll eventually get that in here. Sorry about that. I should have cleared the functions out. Right? So we'll clear. And again, I like parentheses. So we have parentheses, -1 divided by 3. There's my lead coefficient. And then I have x plus 2, and then x minus 1, and then I have x minus 3. Okay, and so when I go graph that, right, we'll see pretty much I was spot on, right? My graph's not too bad. I'm crossing the x-axis at -2, 0, 1, 0, and 3, 0. My y-intercept is at 0, -2, and I'm on my way down. So positive infinity in this direction, negative in that direction, and we're coming down, back up, and then back down again. So it's good enough, my sketch. Not bad, all right, not bad. So let me go ahead and clear that out, get ready for the next one. So how do I give a rough sketch without technology here? Well, again, let's start with what we know, right? Where are my x-intercepts? Well, one of them is x equals to 0, another one is x equals 2, and another one at x equals 3. So we got 0, 0, we got 2, 0, and we got -3, 0. So I have 0, 0, 2, 0, and -3, 0. Alright, so we have those graphs. I also know that this one behaves like a line, right? Multiplicity 1. This one behaves like a line, multiplicity 1, but this guy behaves like a quadratic, right? It's going to basically touch. So cross, cross, and touch. Unfortunately, the y-intercept's the same here, so we'll just deal with that. And then what about my end behavior? Well, if we multiplied everything together, that's degree 2, right? Times another, we're going to have x to the 4th times 1/2 plus a bunch of stuff. So my end behavior is the same. My lead coefficient is positive, so I've got to be basically going up in both directions. So what is this a possible graph of? Well, I basically got to go down to my x-intercept, back up to my other x-intercept, down to this one, and then here we're going to be careful. I'm not going to cross. I'm just going to give it a glancing blow, and then go right back up. So I'm behaving with multiplicity 1 here, with multiplicity 1 here, and then with a quadratic right there, multiplicity 2. And then my end behavior matches up, and there's a decent sketch. If I wanted more detail, perhaps I'd throw in what's happening at -2, what's happening at 1, what's happening at 3, just to give myself more detail. But again, I'm just asking for a quick sketch. And there's a quick sketch with all my needed information. My intercepts, my end behavior, we've got it. So again, let's just go to our graphing calculator to verify that and make ourselves feel happy. Our math should match our information here. So again, parentheses wise, I have 1 divided by 2. I'm multiplying that to x, and then I'm multiplying that to x minus 2, and then I'm multiplying that to, oops, you know what, I think I just goofed up, right? I just realized that multiplicity is there. So before I do that, how about I do this in red? Sorry, we're going to come down, do a glancing blow at -3, then come down and then back up. So let me do a really quick change in red. That's what our graph should be, because I put the multiplicity in the wrong 0. The multiplicity is not at 2. It's at -3. So I don't know why that occurred to me. So parentheses, you guys are probably screaming at me through the video, right? That's why I would love to be back in class. My students can correct me right off the bat. So there's our graph. And what we get is at -3, right, we're giving a quadratic glancing blow. At 0, 0, we're behaving like a line. It's dipping a little bit more than I said it would, but it's basically the general idea, and then coming back up. So end behavior is good. The multiplicity at -3 is good. The multiplicity at 0 and at 2 is also good. It behaves like a line. So my sketch wasn't too bad, especially after I redid it and marked it in red and caught my mistake. So that is what you guys have. Kind of hard to test. I'm going to try to figure out how to test this in terms of quizzes, because I know you guys have your graphic calculators and you're probably busting those out anyways. But I'll figure out a way. All right. But it is kind of, if you can do that real quickly, sometimes you're faster than your graphing calculator, and that's pretty much a good payoff. But that pretty much wraps up section 5.1. So we did some polynomial theory. We got it hopefully familiar with what a polynomial definition is and how we can write them, what their graphs look like and what we should expect out of their graphs. We did some zero theory about what it means to be a zero and the ramifications of that with regard to x-intercepts and factors. And then we were able to do that, to do some graphing as well as to do some curve fitting. So practice hard, study hard. If you have questions, ask. Come see me for a Zoom meeting, ask on Canvas, whatever the case might be, to keep your learning progress going. And now, we'll be transitioning to 5.2, and we'll be doing a lot of new cool stuff. See you then.